Alright guys, today we're going to do something about Taylor inequality to determine error of bounds. So this is the first one. It's about function of e of x. So the expansion center should be centered at a equals to 0. And we're plugging value x equals to 1 to the Taylor expansion function. And then we're going to do is find the Taylor inequality, which is r of 4 of 1 should be less or equals to maximum value divided by 5 factorial times 1 minus 0 raised to the power of 5th. So m here basically it's e to the x, and we're gonna find the maximum value in domain 1 and 0 and 1. So absolutely e of x is an increasing function, so we got the maximum value at x equals 1, so maximum value is e, it's just e, so it's less or equals to e times 5 factorial, which is e over 120. Let's see the second one. Cosine 0.4, so function should be f of x equals to cosine of x, and the expansion center should be a equals 0 because the first term is 1, and then it's at x equals to 0.4. So we're going to do r 4 of x, 4 of 0.4. Absolute value should be less or equals to maximum value divided by 5 factorial times 0.4 raised to the power of 5. So I'm here, it's just f prime f, find the nth derivative, which is f n plus 1 of x of c, so which is f 5 of c. But actually it doesn't matter because it's always 1. The maximum value for cosine, sine, or negative cosine, sine is always 1 for maximum value. So the error of bound should be 1 over 120 times 0.4 raised to the power of 5. Let's see the next one. Estimate the value of e raised to the power of 1.5 by using Taylor polynomial centered at x equals 2. Find the least degree of polynomial need to have error less than 0.001. So what we're going to do is, the function is still f of x equals to e raised to the power of x. And then x should be 1.5 and e and a equals to 2 because it's centered at x equals 2. So we're going to find the least degree, which is we still write down the Taylor inequality, which is r n of 1.5 should be less or equals to maximum value divided by plus 1 factorial times 0.5 raised to the power of 5. So m here, yeah, and it should be less than 0.001, and m equals to f. We don't know how many times prime of the function f prime of c. That's the maximum value at that point. So yeah, that's at the point. And the domain of the function, because that's still e to the x, we're gonna find the maximum value between 1.5 and 2. So 2, it's a e of x is an increasing function, so the maximum value should be e squared, and e squared divided by n plus 1 factorial times 0.5 raised to the power of 5 should be less 0.001. So we're gonna estimate this one. We plugged in calculator and we got n equals to 4. It's 0.00192, which is greater than, a little bit greater than. And when we plug 5, it becomes 0.000160, so which is the least degree that the polynomial have an error less than 0.001. Let's see the last question. Let f be a function having derivative of all orders of the real number for all real numbers. The third degree Taylor polynomial for f about x equals to 1 is given by p of x equals to 6 minus 9 times x minus 1 squared plus 4 times x minus 1 cube. Suppose the fourth prime of x, it's the absolute value is less or equals to 6 for all x on the interval of 0 to 1. The Lagrange arrow bound to justify why f0 is negative. So we still start with the expansion p, so it's raised to the power of 3, so it's 3, so it's third degree, so p3 of x should be equals to f prime of, so f of, oh, it's f of, so it's started at 1, so f of 1 plus f prime of 1 times x minus 1, and we do got plus f double prime of 1, x minus 1 squared divided by 2 factorial, and we got f third prime of 1, 3 factorial, x minus 1 cube. So f of 1 is 9. F prime of 1 is 0 because there's no x showing up on the polynomial. F double prime of 1 should be f double prime of 1 divided by 2 factorial equals to negative 9, so it goes to negative 18, and f third prime of 1 it goes to 3 times 2 times 4 is 24. Okay, that's what we got so far. Yeah, that's what we got so far. Okay, that's what we got so far. Yep, that's what we got so far. And then, so we're estimate f of 0, it equals to p of 0, which is 6 minus 9 plus minus 4, so it's negative 7, but we still gotta add up the arrow to it. We still need to add up a 0 arrow so that we can estimate the upper bound, lower bound of the Taylor inequality. So arrow are 3 of x absolute value should be less or equals to max value divided by 4 factorial times times 0 minus 1 raised to the power of 4. So m here, which is m equals to f prime, f fourth prime of x, and it's absolutely less or equals to 6, so maximum value should be here at 6. And we got it's 6 divided by 4 factorial, and absolutely when we add the arrow to it, arrow, it's still negative because 6 divided by 4 factorial is so much less than 7. So whatever we minus it or plus it to -7, it's less than 0. So that's the reason why f of 0 is negative. Thank you for the video. Thanks for watching, and hope you guys have a understanding of the Tyler inequality. See you later.